The oldest impact craters disappear from the face of the Earth. There's a reason why scientists haven't been able to find any craters older than about 2 billion years. Constant erosion and geological processes on our planet have likely wiped him out completely, leaving only faint traces of ancient impacts in the form of molten rocks or minerals formed under extreme pressure, according to new analyses. The oldest craters on Earth could provide scientists with valuable information about the structure of the early Earth and the composition of bodies in the solar system, as well as help interpret craters on other planets. But geologists can't find evidence of impacts older than about 2 billion years, and according to recent analysis, they probably never will. All because of the constant process of erosion. The description and results of the research were published in the Journal of Geophysical Research, Planets. Analyzing the structure of the oldest impact craters on Earth could provide scientists with valuable knowledge. Unfortunately, geologists may no longer be able to find them. At least not entirely. Yes, it is possible to find other evidence of a space object hitting the Earth's surface, such as material ejected from the site, molten rock, or minerals from billions of years ago, which were formed with the participation of high pressure. However, the oldest craters we can find are only 2 billion years old. Unfortunately, in the case of even older ones, the destructive effects of the passage of time, but above all erosion, did the job. So we should be happy with what we have and what we can explore. Sometimes geologists are able to track the impact sites of space objects with the help of seismic imaging, for example. In such situations, an attempt can be made to find the aforementioned evidence. One could also pose the question of how far down the crater would erosion processes have to reach for the last geophysical evidence of the impact to disappear. Geologists have proposed a value of 10 kilometers here. South Africa is home to the Vredefort crater, which was formed when an object about 20 kilometers in diameter created a structure as large as 300 kilometers in diameter some 2 billion years ago. The force of the impact was so great that it caused the crust and mantle of the Earth to rise in this place, which took the shape of a huge dome. In the meantime, however, erosion began to work, which penetrated about 10 kilometers into the crater. Currently, only a semicircle in the center of the resulting structure remains. Only the center is still detectable. However, there is no geophysical evidence at this point. So the researchers decided to look for them more thoroughly. Rock samples over an area of 22 kilometers were analyzed for their physical properties, trying to capture the differences between those formed at the moment of impact and other rocks. The focus was on the density, porosity and mineral content. Modeling of the previously described impact and its impact was also carried out to determine which rocks should be looked for in such a situation. However, the results obtained turned out to be disappointing. In the case of this 2-billion-year-old crater, some minerals remained, as well as signs of melting of the rocks. But for the most part those present in Vredefort were indistinguishable from those found outside the area. So in the case of even older craters, we could not count on success. Geologists' predictions of an erosion limit of 10 kilometers turned out to be extremely accurate. Scientists have genetically modified a plant related to tobacco to produce cocaine. Scientists in China have for every 10 disc-shaped beads plant, a relative of tobacco called Nicotiana benthamiana, produces cocaine in its leaves. The research team found that they had learned how the coca plant produces cocaine, and they replicated the process in another plant. Cocaine is more commonly known as a drug or drug, but it also has potential in medicine. Even in the 19th century, it was used as an anesthetic, and these properties are beginning to be appreciated again. For years, scientists have been trying to develop a method of quickly and cheaply synthesizing cocaine. It seems they finally made it. Scientists in China say they have determined how the dwarf, also known as the coca bush, Erythroxylum coca, produces cocaine in its leaves. The researchers recreated the known cocaine biosynthesis pathway in another plant, a modified tobacco relative, Nicotiana benthamiana. The description and results of the research by scientists from the Kunming Institute of Botany in China have been published in the Journal of the American Chemical Society. Secrets of the coca bush naturally occurring in dwarf cocaine. Cocaine is a tropany alkaloid that acts as a short-term central nervous system stimulant and local anesthetic. Cocaine is better known as a drug, but it also has properties that scientists are interested in. For example, in the 19th century, this stimulant was successfully used as an anesthetic or to constrict blood vessels to stop bleeding. Recently, the U.S. Food and Drug Administration, FDA, approved the use of cocaine as a local anesthetic for mucous membranes. Scientists have been trying to determine how the coca plant produces cocaine for decades. It's a complex biochemical thing, and while the researchers mapped out most of the plant's processes, they missed a key element: how exactly a chemical precursor called MPOA is converted into cocaine. Researchers focused on MPOA because the same precursor produces a similar tropany alkaloid called hyoscyamine. In the synthesis of hyoscyamine, MPOA is converted to MMPO, leading scientists to conclude that the same pathway must be involved in cocaine production. However, in a new study, researchers in China have found that MMPO is not involved in the production of cocaine. Instead, MPOA is converted into cocaine by the activity of two enzymes called NCYP81AN15 and ENMT4. To prove this, scientists genetically modified the Nicotiana benthamiana plant to produce these two enzymes. Nicotiana benthamiana contains substances similar to MPOA, which is why it was selected for research. The modifications led to the synthesis of cocaine in the leaves of the plant. And although the relative of tobacco yielded a paltry, but still exciting 400 nanograms of cocaine per milligram of dried leaves, or roughly 1/25 of the yield of the average coca plant. The fact that the cocaine biosynthetic pathway has been unraveled opens up the possibility of mass production of the substance in other organisms, such as E. coli bacteria. Scientists reassure that their breakthrough will not cause huge amounts of the drug to appear in cities. It is unlikely to affect the availability of the drug at all, as the process of genetically altering another plant or bacterium to synthesize the drug is well beyond the capabilities of even the most sophisticated drug cartels. At least that's what scientists believe. Besides, they emphasize that their research was not aimed at developing a method of producing cocaine for recreational purposes, but for medical applications. My main motivation for tackling the issue of cocaine biosynthesis was scientific curiosity. It will now be possible to construct various cocaine analogues for drug discovery. However, we do not know if we will be able to obtain stimulants that will have reduced psychoactive properties, said Dr. Shengsheng Huang, the lead author of the study.